Yeah, so senior 6, I left the assignment. I hope you tried it out. Some of you yet given back feedbacks. I'm trying to go ahead and finish this topic of projectiles. So here we have a body which is projected above the horizontal. So a particle is projected at an angle of 40 degrees. You have it here. The horizontal at a speed of 36 meters per second. That's our speed it begins with. And it's above the level ground, 0.5 meters. It's above the ground. Yes? Like kicking a ball above the ground. So not on the ground exactly, like when a keeper holds the ball and kicks it, it's normally it's above the ground. So here, the ball is being given off an escape velocity above the ground of that 36 meters per second. It just clears a wall. There's a wall here. It's clear the wall here. There's a wall here. Can be a building of a kind. And the wall, which is 70 meters on the horizontal plane. 70 meters on the horizontal plane. So they're asking us to find the time taken for the particle to reach the wall. So already we have the distance from here up there is 70 meters. The horizontal displacement. So we come here. This diagram normally carries some marks like 2 or 3, 4. When we come on this formula here, the second unit of motion, our S is displacement, X horizontal displacement, U cos theta is the horizontal speed, and T is time taken. But they're asking for time. I already have the distance, X is 70, 36 is our speed, our cos, so they know the angle, find T, and we come to that. So our time we approximate it to that. Now, secondly, we look at we have been asked to find the height of the wall. But to find the height of the wall, I must first find this height here plus the height which was below here. So how do we find this height here? I go for the vertical displacement. Still for the second equation of motion, where you have now S called there Y, it's a vertical displacement. Here we now have sign because it's vertical motion. Then G becomes negative. From there, my Y simplifies to this. Normally, don't round off very fast because you haven't yet what added yet. Then the total height here becomes this one here plus this. This one here is the Y plus 0.5 here we had. We come and we add the 2. When we add the 2, we come to 27.66 meters to 2 decimal places with a calculator. That's how we find this height of the wall, in this case of the question. Part B, we have been asked to find the maximum height reached when it's moving. There's a height here, it's covering, yeah? But the maximum what? Height. If I call it H, maximum height. So there's already the height down here, 0.5, and we get this height here. So if I call this height H prime, so I first find this H prime here. How do I get H prime? I've said maximum height is equal to H prime plus that. But from the third equation of motion, we said at the maximum height here, the body is as if at rest. It has reached the maximum height, and we move back downward. It means here our V is 0. You simply put our U sin theta minus 2G H prime. H prime is the height from here up to here, not the whole height, only from here up to there. Then down there, you can simplify and get your H prime as this. You know U, you know the angle, you know the G. Put them there. Normally G is 9.8 and we will provide it on the first page of the question paper. We are aware already I have 0.5 here given, this one here, add the 2. When you add the 2, you round off to give 27.82 meters to 2 decimal places with a calculator. I'm going to give you work to try out in photo form and keep practicing.